Ladies and gentlemen, a very warm welcome. Thank you very much for the possibility to give you some slides for our topic at local district heating project with integrated greenhouses in Germany. And thank you very much also to the program committee to give us this possibility. And we are speaking about the high acceptance from an innovative heating price system. And my colleague Manuel and me, we are from the economic side view. And yes, we hope to see us at October in Reykjavik. So I will start with our introduction, and then Manuel will come with the next slides. Rödl & Partner is a one-of-a-kind company. We are founded in 1977 in Germany, in Nuremberg, and now we have our 5,000 colleagues all over 50 countries with 111 fully owned offices. We are one firm, not a network or a franchise system, and we have services like legal, tax declaration, BPO management, and IT consulting and auditing, of course. And we are committed to German international active family business, but also to all other business. And yes, we are always focusing on numbers and paragraphs. In the deep geothermal, we come from the point of view of public management. There we founded this sector at 1990. In 2002, we started the project management of the first plant in Germany, all with the economic and the legal view. Today we are all over the planet. You see our little signs there. We have, especially maybe the GRMF fund in East of Africa, where we are located in Addis Ababa in Ethiopia. Maybe you know this project, but yes, and abroad we are also with this economic and legal topics. In Germany, we are speaking about the project in Kirchweidach. This is near the Austrian border in the southeast of Germany. The drillings there were finished in 2011, and then we built up, there was built up a district heating network with 400 properties and various greenhouses. This amount of 121 gigawatts thermal energy, which is completely CO2 free, and we are saving there 38.6 million kilogram of CO2. So this is really a great project, and was filled with or get a Global District Climate Award in 2015. And maybe you can give there in the internet some more information on the web over this project. But we are speaking about the German heat market and what is the innovative character of this. So you see the market is in Germany like 11% of the heat market is with renewable energies only. 89 is gas and other fossil resources. But the possibility, the potential of a deep geothermal with hydrothermal especially is up to 260 terawatt. So we could double the today renewable energy if we use the deep geothermal. So we are yes on a way up to use the deep geothermal energy, and of course it's also an economic and legal topic. Of the economic view, you have to see there is efficiency higher, so maybe the market is going smaller. And in the heat market, we want to save a lot of energy from 840 terawatt hours the year to down to 425. But we have the Wärmezielscheibe to see in which regions this will be. And this sparsely populated region is lowering a lot, but the densely populated region is it's not possible to make such a high amount of efficiency. So we are focusing in this region, and there you can use the district heating because the district heating systems, and deep geothermal is there the main energy. You can use it there. So we are happy to have to be a part of this new growth from deep geothermal. And now I give to my colleague Manuel, give the next slides.
Thank you, Benjamin, for the introduction of the geothermal market in Germany and the successful project in Kirchweidach combining geothermal heat and greenhouses. Looking at the positive results of the cooperation, the question why this is a one-of-a-kind implementation arises. This is why we frame two target questions for this presentation. Firstly, is the success story from Kirchweidach suitable for other geothermal projects? And secondly, if that is the case, what are the key success factors that can be adopted for future projects? To tackle these questions, we conducted SWOT analyses for both geothermal energy and greenhouses to outline respective determinants. A SWOT analysis looks at strength, weaknesses, opportunity and threats, whereas strength and weaknesses examine the internal, presenting advantages and disadvantages. Opportunities and threats, on the other side, examine the external and therefore future considerations that stimulate or jeopardize further undertakings. On the following slides, we will look at the results of the two analyses. Also, we will compare both results and derive a conclusion regarding the target questions. Let us start with the SWOT analysis of geothermal projects. One of the most eminent positive characteristics of geothermal energy is the regional value creation, as it enables the community to support and reintegrate the regional economy. The second internal strength is the autonomous subsistence. On the one hand, geothermal is able to be used as a baseload source of energy and, on the other hand, is mostly independent from turmoil in international financial and oil markets. Once the drilling site is operating, geothermal provides long-term planning security, as first projects in Europe are closing in on a production period of 100 years. The renewability and space efficiency of geothermal round up the positive internal aspects. Focusing on external positives, public support is crucial. After overcoming the threat of a negative public image, public acknowledgement has been present at various projects, even culminating in pride of the local achievements. The substitution of fossil fuels will become more attractive for end users and investors in the upcoming decades. Besides ecological reasons, other aspects such as emerging emission fees, as introduced by the German government just last year, will make geothermal projects more economically appealing. Despite the positive outlook, one might not forget about the project weaknesses and threats. These include the high initial investment cost, the long development period, and the dependency on location that might be combined with the exploration risk. TV or local coverage might not be able to handle these points, which might subsequently lead to a negative image. The competition, or more specifically the lack thereof, is a threat that has led to a slow development, and geothermal failed to reach its full potential yet. Missing or insufficient governmental support has also not helped geothermal in the last decades. Combined, these aspects might lead to uncertainty, which is tough to overcome. Switching to greenhouses, internal agricultural aspects stand out. The fertile grounds provide agricultural potential and diversity, autonomy from weather and suppliers, secure long-term planning, and enable ecology of scale. Furthermore, jobs are created all year round, leading to regional value creation. In the future, technological progress will reduce costs and environmental aspects will thrive. Public support as well as social engagement will also show positive when shifting towards carbon-free greenhouses in the future. Right now, the main weakness of greenhouses is the high energy consumption and thus the dependency on fuel costs and energy prices. Collaborations with renewable energy sources might overcome these weaknesses. Another point might be the reluctancy of investors, because the density of information is low at the moment. To sum up those aspects, new and innovative projects might generate initial distrust that has to be remedied. Comparing both analyses, geothermal energy and greenhouses have a substantial overlap in their SWOT analysis results. The merger between geothermal energy and greenhouses mitigates numerous risks of greenhouses. By creating long-term ties, greenhouses become increasingly autonomous, ensuring the subsistence in solitude of developments in the international energy markets for fossil fuels. Furthermore, the partnership also benefits the geothermal project. Due to the high initial investment costs, planning stability is a significant component of geothermal energy projects. With the steady heat demand, the geothermal focus can be shifted away from electricity production, and heat extraction and electricity production can both be achieved. Thus, geothermal and greenhouses form an ideal combination. Both partners are interested in long-term contracts and security, concluding in price stability. Hence, exploration risks are alleviated and profits are achieved. The sustaining contracts lead to resilient business planning and interest from investors, eventually increasing the profitability of both projects. Looking at the example of Kirchweidach, two key success factors could be identified. Firstly, actively approaching the community and an open strategy of communication led to high acceptance by internalizing negative externalities. This was achieved by open discussion, information seminars and guided tours through the premises, eliminating the initial distrust and helping shaping a positive image of geothermal energy and greenhouse farming. Secondly, an innovative heating price system was developed following an opportunity cost approach. As shown in the diagram, electricity production is subject to the available thermal water flow rate and the ambient temperature. Depending on the proportional heat extraction of the greenhouse, shown by the different lines in the diagram, and the ambient temperature on the x-axis, the possible electrical output differs. The developed heating price system accounts for foregone electricity production as the opportunity costs of heat extraction. This way, the revenue from the heat extraction balance the foregone electricity profits. Moreover, the system is transparent for both partners and ensure long-term profitability as well as planning security. Looking back at the target questions, a partnership between geothermal and greenhouses are possible elsewhere. The analyses showed that the collaboration leads to a long-term profitability for both partners, as secure planning leads to more robust business strategies and autonomy. By using carbon-free energy, greenhouses become more sustainable and push the decarbonization forward. Energy and food consumption rely heavily on imports. By using geothermal energy and farming in greenhouses, the value creation becomes local, adding value to the community and the municipality. As shown, the two key success factors are the social engagement and an innovative pricing system that accounts both heat extraction and electricity production, while being transparent for both parties at the same time. In conclusion, we plead for more sustainable energy projects in the agricultural sector. In the future, heat-driven projects round up the portfolio of investors and policymakers. Now is the time to use the geothermal potential and rise to the occasion. We thank you for your attention and will be available to answer your questions.